Hi, so I got another question from a student. This student is working quite a bit ahead of schedule. So this is I think it's a chapter 7 or 8 question probably. And so I'll solve it anyway, but be aware that you don't necessarily need to be able to perform this equation or do this problem until later. So let's go. So for for the reaction given below, calculate the following. It reads the nitrogen tetroxide, which is an oxidizer for rocket fuel, something I worked with very closely for a long time. Nasty, stinky brown stuff. Back to two NO2s. It has a constant, a coefficient of 7.19 times 10 to the minus 3. The problem reads, what is the molar concentration? Now, if you read this, if you see these brackets here, that means molar. That means moles per liter, and so many of you have no idea what that means yet. It's okay. It's a concentration. It kind of means like percent or something. All it tells us is how to write moles per liter here. The answer at equilibrium, meaning that when everything's done reacting and it meets some steady state, when the molar concentration of this part, which is this stuff right here, is 0.0255 moles per liter, what is the concentration of the other stuff? So this number here tells us that relationship, and here's how that number works. This number is called an equilibrium constant, and the K value for this stuff, here's the answer, by the way. K is always going to be equal to the, it's always equal to the ratio of the products over the reactants. And how do I know what a product and a reactant are? Well, anything on the right side is a product. Whoops, sorry, I'll move that around. Is a product, and everything that's on the right side, and the left side is a reactant. This is an R. That is a reactant. Let me scoot this up here. And so here's how, and it's a little more complicated than that, because this number here, this coefficient, you raise the products to that power. And I'm not trying to make this problem more complicated than it needs to be. If you had more than one product reacting, we'd do things slightly differently. I'm just trying not to make it too complicated. I'm just trying to solve this one problem. And so what we'd have to do is you put the product to the power of this coefficient. This one's 2, so you'd put a little 2 up here. If it were 3, you'd put a 3 up there. So in this particular case, here's how we write this problem. We say K value is equal to NO2, which is a product, and a gas. I'll put it in little brackets because it means molar concentration, to the power of 2, because there's a 2 right here, there, divided by the molar concentration of the reactant, which is N2O4 nitrogen tetroxide. And that's what this relationship is. There's a number that always describes the ratio of this concentration to that concentration. That number is K. It's given to us in this problem. So I'll change colors a little bit, and I'll just sort of write the same thing down here with as many numbers as are possible. And we're given this K value. It is 7.19 times 10 to the minus 3. We are given what else here? NO2, which is 0.02. It's 0.0255 squared. That's what that means. This is a squared sign. And it's divided by N2O4. So we're trying to solve for N2O4. So how do we do that? Well, we say, okay, we multiply this to the other side, and then we get, I might have to move some of these things around here to give myself some room. So let's just kind of take this. Let's do that over again. Scoot this up, because I'm going to just kind of scoot that over there. And so we're going to do this, continue this math here. We're going to say, okay, well, we now have N2O4 times 7.19 times 10 to the minus 3 equals 0.0255 squared. And then we need to isolate this variable. So we're going to say, hey, well, we just N2O4 is is equal to, and we're just going to divide this on the other side, 0.0255 squared divided by 7.19 times 10 to the minus 3. So we solved this problem and we got our answer. And so let's try it on our handy TI-84 CE color calculator. And so the problem is, and I'm going to scoot the problem off screen so we can more closely focus on the math here of what I'm doing. And maybe I can scoot this in such a way that you can see both at the same time. That might be, yeah, I really can't do it. Let's see. So I'm going to go ahead and just do the problem here for you. And it's 0.02. The problem is 0.02, and you can follow my keystrokes here. 55 squared, and then that problem is divided by, and it's going to be 7.19 times 10 to the minus 3. So how do we enter that? We say 7.19. Let's see this little double E symbol here. So we're going to go second function double E, which means times 10 to the, and then not minus, but negative 3. We don't press minus 3. That's a no-no. We press negative 3. And that is solving this problem, 0.0255 squared divided by 7.19 times 10 to the negative 3. And we press enter. And we get a value of 0.0904. And that's 3 significant figures, and that's the answer I said is the right answer here. And it's 3 significant figures because there are 3 significant figures here. The other problem here that you see, and I shouldn't say problem, the other exercise that we see, let's erase some of this stuff, is exactly the same format. I'm not going to solve this one, but I will set it up for you because I think I should leave you some work to do yourselves. But if we were to, what color do I like? I like purple. Purple sounds good. So we would do sort of the same thing, just a little bit changed around. We say that we have the K value still, so we would say, hey, well, the K value of 7.19 times 10 to the negative 3 is equal to, now remember we had in the numerator, we have this guy here, which is the product, NO2, and squared. And last time we had that value, but we don't this time. So it's NO2, whatever that concentration is, squared. And that's going to be divided by this value, N2O4, which is 0.0736 moles per liter. So I'm not going to do as fancy of isolating of variables anymore, but what you're going to end up getting is 7.19 times 10 to the minus 3 times 0.0736 is going to be equal to NO2 squared. NO2 squared. So then I'm going to take the square root of both sides here, and I'll get the square root of this side of a square and the square root of this side here. And so the square root cancels out the square, and so the NO2 is just going to equal the square root of this times this, and that's the answer. And that's going to be over here. You're going to find that it is this value here is 0.0230 moles per liter. And again, you don't have to do that yet. It's going to be you're a few weeks out from this, but you can watch this video when you're ready. I hope it helps.